So in order to use this formula, which is the sum of an infinite series is T1 over 1 minus R, the series has to converge, which means that the R value, the absolute value of the R value, has to be less than 1. So let's look at these 3 questions and figure out which one has a sum and which one does not. So looking at question number 1, I think we're on page 12. The R value is 7 over 3. Can I use my formula or not? Who says yes? Who says no? It's no. And why is it no? Because 7 over 3 is greater than 1. So this has no sum. The numbers are getting bigger and bigger. And you don't have to know the definition. I mean, the word diverge versus converge. But, you know, that's why. If the numbers are steadily getting bigger, we can't figure out the sum. All right, let's look at question number 2. We got 0.4. Is 0.4 greater than 1 or less than 1? Less than 1. So yes, we do have a sum. So my T1 is 2/3 and my R value is 0.4. So type it in your calculator. You would say the sum is equal to T1, and that's divided by 1 minus 0.4. Go ahead, take a moment and type that in. So I got 1.11 repeat. That's what I got. Who got that answer? So that would be your sum. Go ahead and just type it in your calculator. That is what you should get. Yeah. I mean, you could do it. You would have to take the 2/3 and then divide that by 0.6, which is the same thing as 2/3 divided by 3 over 5. Then you would have to do keep change flip, which would be 2/3 times 5 over 3. And that's going to give you 10 over 6. Sorry, 10 over 9. So yeah, that would be with that. So you would have to know how to convert to a fraction, a decimal to a fraction, how to divide a fraction. But yeah. All right, let's look at part C. All right, do we have a sum? Who says yes? Who says no? We do. Because we're looking at the absolute value of my common ratio, which is just 2/7. 2 over 7 is less than 1, so we do have a sum. So T1 is 8. R is negative 2/7. So let's go ahead. Hold on, let me get some more space. To the left. Or to the right. Okay. All right, so the sum is going to equal 8 divided by 1 minus negative 2/7. Now, you can change that to a positive because the 2 over 7 doesn't have an exponent. So you could change that to 8 divided by 1 plus 2 over 7. And that would be your answer as a fraction or as a decimal. Anybody need help typing it? You need help typing it in? Whose calculator gave it as a fraction?
I was in it first.
It did. Okay. I'll take either one. Fraction is honestly always better, but I will take, because you don't have to round the fraction. But I'll take either one on the test next week. Test is next Wednesday. All right, so now, oh yes, sorry. You didn't get that. Okay. Let's see. This is 1, not 2. So it should be 1 plus 2 over 7. Okay. So now let's look at the last few questions and then we will round out with Pascal's triangle. See how far we can get. Probably through most of it. So this is saying find the first 2 terms, and they told us it's an infinite geometric sequence. But they didn't tell us T1. So the first thing we have to do is find T1. We're going to do that using our formula. So we know that the sum of an infinite series is equal to T1 over 1 minus R. So I know my sum is 10. I don't know T1, but I know that my R value is 0.2. So we just simply need to solve this for T. So the first thing I would do is simplify my denominator. Let's figure out what 1 minus 0.2 is. $1 minus 20 cents. 0.8. So we have 10 equals T1 divided by 0.8. Now, in order to cancel out your fraction, we just multiply both sides by our denominator. So I'm going to multiply this side by 0.8 and this side by 0.8. That's going to cancel that out. So figure out what 0.8 times 10 is, and that's your first term. So you should get that T1 is 8. How do you find T2? What are we going to do to find T2? Multiply it by what? 0.2. Because remember, our multiplier is 0.2. So in your calculator, take 8 times 0.2. Would you get 1.6? Yeah? Okay. Because remember, it's an infinite sum. So the numbers, T2 should be smaller than T1. Okay, because an infinite sum, the numbers are getting smaller. So after you find T1, if you get a number bigger for T2, then you did something wrong. All right, go ahead and do the last question by yourself. Take a look. So when you set up your equation, you have 12 equals, and then it's T1 divided by 1 minus R. So I got that T1 was 8.4. This is your R value though. This is what you're multiplying by. Some of you were multiplying by 0.7. That's not what you're multiplying by. The equation says 0.3. So after you find your first number, you multiply that by 0.3. Also, remember what I said. If your second number is bigger than the first, that should be a red light that I did it wrong. In an infinite sum, the numbers are getting smaller. So, questions? Yes. Yeah, the pass is on my desk. Okay, let's finish it out. Let's talk about Pascal's triangle. It's a pattern to multiply binomials. So the pattern says, okay, this is homework 25. I don't think I have the right due date. That should be Tuesday. It's due on Tuesday the 9th. So change that. This is due on Tuesday the 9th. So Pascal's triangle is a pattern. So the first row, this is actually called row 0.
Oh.
Because anything to the power of 0 is what? 1. So that's why we start off with row 0. Then the second row is 1, 1. Now that is actually row 1. So this is row 1. We call this one row 1. Now in this triangle, you always start the row with 1 and you end it with 1. So let's work on row 2. Row 2, I'm going to start with a 1 and end with a 1. The middle number is what I get when I add these together. So what do you get when you add those two numbers together? 2. So row 2 is 1, 2, 1. Now let's look at row 3. So I'm going to start with the 1. I'm going to end with the 1. All right, so now I got to add these together. What's 1 plus 2? 3. What's 2 plus 1? 3. Notice that every row we're adding a number. All right, let's look at row 4. Start with the 1, end with the 1. So now I'm going to add these together. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. That would be row 4. All right, we'll go down to row 7, then we'll stop there. It doesn't end. It goes on forever. So let's look at row 5. Start with a 1, end with a 1. You got 1 plus 4, which is 5. 4 plus 6, which is 10. 6 plus 4, which is 10. 4 plus 1, which is 5. Let's look at some of the patterns that we can kind of establish. After you get past row 0, notice that the second number is the same as the row number. So see how this one, the second number is a 1? That tells me that's row 1. Here, the second number is a 2. That tells me I'm in row 2. Second number here is a 3. I know I'm in row 3. Okay, so it's a pattern. Also notice that as we go down the triangle, we're adding an additional number. So we start off with one number, then it's 2 numbers, then it's 3, 4, 5, 6. I want you to try to fill in row 6 by yourself, and then we'll go through it together. Row 6 should have 7 numbers. All right, so second number, what did you get for your second number? 6. So it should match the row number, right? So second number is 6. Then here, 5 plus 10 is 15. And then we do 10 plus 10, which is 20. And then you notice that it's symmetrical. So once I hit that middle, the other side is going to be symmetrical to the left. So that means I already know that my next number is going to be a 15, and this number will be a 6. All right, last row, do row 7 by yourself, and then we'll end there.
Oh, wait, so we're done. What did they have in row 7?
I can't hear you.
So, now,
Wait, what's she saying? What's she saying?
Are we done now after done?
Yeah, after 7, we're done. Yeah. So you will be asked to build a triangle. The last question on your final is the Pascal's triangle. After this, we have covered everything for the fall semester of pre-calc. Okay, so my next number was a 7. And then 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. So who had that for their row 7? Okay, and again, it just keeps going. It doesn't end. So now, how does this apply to binomial expansion? So in the past, we would make boxes to multiply. But if I'm asking you to multiply something to the 5th power, making boxes is going to take a long time, which is why we use Pascal's triangle for higher exponents. So let's go ahead and look at this first one. First thing I want to identify is what row. Because it says 4, the first thing I'm going to do is look at my Pascal's triangle and write down the numbers in row 4. Yes. Okay, what does yours say? I kind of thought I changed it, but I wasn't sure. Oh, wait, what does he say? Oh, yours doesn't say that? You don't have that page?
well, I have it, but it says minus.
Oh, you're doing the homework. We're in the notes.
Oh.
It's okay. I was like, what? We're here. Okay. I was like, wait a minute now. Okay. So let me go to row 4. So row 4, the numbers are 1, 4, 6, 4, 1. So I'm just going to write those numbers because that's the row we're in. So what this tells me is that my final answer is going to have 5 terms. Okay. So what I want you to do, let's look at the first term because it's only for a binomial. So we can't use this for a trinomial. It can only be 2 things. So I'm going to start off with A, and I'm going to give myself some space. I'm going to write A to the 0, Then I'm going to give myself some space. A to the 1, A to the 2, A to the 3, A to the 4. With my second term, which is just B, I'm going to start with the highest power and go backwards. So here I'm going to write B4, B3, B2, B1, B0. And then I'm just going to stick those numbers in front. So I got a 1, a 4. Let me put a plus sign in between. A 6, a 4, and a 1. Okay, so we've actually done the hard work. All we need to do now is simplify it. First of all, anything to the power of 0 is what? 1. So I can actually cancel out this term and this term. So my final answer, when I multiply these together, 1 times b to the 4th, I just get b to the 4th. Plus, when I multiply these together, I get 4ab cubed. Plus, when I multiply these together, I get 6a squared b squared. Plus, when I multiply these together, I get 4a cubed b. And when I multiply that together, I have a to the 4th. That is my answer. That is what you get if you take a plus b and multiply it 4 times. So each one, I should probably have highlighted it. So each one is a term. So this is a term. That's how I got that. This is a term. Okay. That's how I got the second number. And then this is a term. That's how I got that number. And then this is a term. That's how I get this. And then lastly, this is a term. That's how I get that. You ready to do another one? Let's go. Let's look at question B. So now we got row 5. I'm going to have to erase this because I'm not going to be able to fit 2 of them on one page. Okay, so row 5. So the first thing we need to do, let's look at our triangle. Let's write down everything that you see in row 5. The numbers. So the numbers are what? 1, is it 1, 5? 10, 10, 5, 1. Okay. So on the last example, let me go back. I want you to notice that I started with the a to the power of 0 and I worked up. And then B, I started with the highest and I worked down. It doesn't matter which way you do it. Okay. One of them needs to go up and the other one needs to go down because your answer is symmetrical. So for this one, I'm going to do it the opposite way. It's still fine. You get the same answer. So now I'm going to start with the first term, which is x. I'm going to start with the power of 5, and I'm going to go down to 0. You want to give yourself some space. So I got x to the 5th. And I just want you to count all the way down. And you don't have to put x to the 0 because we are going to cancel that out. But for learning purposes, I'll just put it. And if you want to, let's go ahead and stick our numbers in front. And then we're going to take the -3. Whenever it's a negative, I recommend you put it in parentheses. So I'm going to take this -3. I'm going to start at 0 and go up. So I'm going to put -3 to the power of 0. -3 to the power of 1. -3 to the power of 2. -3 to the power of 4. I should have gave myself a little bit more space, but it's okay. Well, actually, let me give myself a little bit more. I'm telling you, I always say I'm going to invest in a real Apple Pencil because this thing is just so raggedy. Okay, so this is x to the first and then x to the 0. Okay, so now I'm at oh wait, why did I make that a 4? Let me go back. What should that have been? A 3, because I skipped over 3. So that should be to the power of 3. This is -3 to the power of 4. And this is -3 to the power of 5. So let me go back. Let's talk about another pattern that we see here. These are 5 different terms. This is a term. This is a term. This is a term, even though it's really close together. But this one here, this is a separate term. This is separate. And then we have this one, which is separate. And then lastly, we have this last one. That's separate. All right, so all together, we have 6 terms. Okay. The one thing I want you to notice, because we're in row 5, I want you to notice that every single term, the powers add to 5. This 5 plus 0 is 5. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 5. 1 plus 4, 5. 0 plus 5, 5. So you want to check that. Okay, so now let's just simplify it. So from here, we just put it together. First thing we know we can do is cancel out this because that just equals 1. So my first term is just 1x to the power of 5. And I always just put a plus sign. Now, for this one, though, I want you to notice that we have 2 numbers that we need to multiply together. I need to multiply 5 and -3 to the first power because we have 2 numbers. -3 to the first power is just -3, and 5 times -3 would be -15. So my next term would be -15, and it would just be x to the 4th because we only have 1 variable. So each term just has 1 variable. Now let's bring down my plus sign. Let's do this one. Multiply 10 times -3 squared. So -3 squared, 3 times 3 is 9. Do we agree that 3 times 3 is 9? And what's 10 times 9? 90. So that would be 90x cubed. All right, now I'm at the purple term. Now I have -3 to the power of 3. -3 times -3 times -3 is -27. -27 times 10 is -270. And that would be x what? Squared. All right, go ahead and do this next one. Figure out what -3, if you're using a calculator, make sure you put the negative in parentheses. -3 to the power of 4 times 5.
Miss Bryant, instead of doing like x to the power of 5, x to the power of 4, but instead like reversed it and did x to the power of 0, x to the power
Yep,
of
it's the same
Okay.
answer. It's just yours is backwards, but it's
Yeah.
still the same answer.
Okay.
Yeah, same answer. Okay, so -3, I think that's 81. 81 times 5, is that 405? So we got positive 405x. And then lastly, All right, I don't know negative 3 to the power of 5. I want to say it's negative 243. Is it? Okay. And then this cancels out because that's just x to the 0. Negative 243. So for yours, Mia, was it the same thing but just backwards? Yeah, same thing. That is your answer. So you just can't go fast. It's a pattern. All right, I think we got time to do one more. Let me see which one I want to do. Okay, yeah, we can do this one. So we're in row 5 again. So row 5, my numbers are 1, 5. Let me try to give myself a lot of space. 10, 10, 5, 1. Okay. Then we're going to start off. Now you could either start this off with x to the power of 0 and go up, or you can start with x to the power of 5 and go down. You get the same answer. So I'm going to start off with x to the power of 5 and I'm going to go down. So I'm going to put x to the power of 5. Then I'm going to put x to the power of 4, x to the power of 3, x to the power of 2, x. And then at the end, you don't have any x's. But I'll still put it. Normally I wouldn't. I just wouldn't put an x at the end, but I'll put it. All right, now let's do our positive 5y. So positive 5y, I'm going to start with a 0. Positive 5y, start with, that goes to a 1. Positive 5y squared. Positive 5y cubed. Positive 5y to the power of 4. And then positive 5y to the power of 5. And now you're just simplifying it. And just go one term at a time. This is your first term. Simplify it. See what you get. This is your second term. Simplify it. See what you get. This is the third term. This is the fourth term. This would be the, I didn't mean to use the same color. This is the fourth term. This is the fifth term. This is the last term. So let's just go one by one. Starting off with the yellow. First of all, that 5 to the 0 is going to go away. Cross that out. So my first is just going to be x to the 5th. Bring down your plus sign. Now, realize that in this term, I have to multiply 5 times 5 to the 1st. And 5 times 5 to the 1st is 25. But I also have 4 x's, and I do have 1 y. Bring down your plus sign. For my pink term, I am multiplying 10 times 5 squared, because everything in the parentheses is squared. So 10 times 5 squared is 250. And this one has 3 x's and 2 y's. Remember, every term, the power should add to 5. For here, I have a 10, and that's times 5 to the power of 3. Which is 1250. X squared, y cubed. And this next term, I have a 5 times 5 to the power of 4. Oh, for real? I thought it was 625. 3,125? 5 to the power of 5? Okay. 3,125. 1x and 4 y's is with that last one, or with the next one. And then for the last one, We just have a 1. This goes away. So the only numbers I have left, again, is another 5 to the power of 5, which is going to be 3,125 y to the 5th. All right, we only have a couple more, but this is everything. There won't be any more new material introduced for the test or for the final. Monday, we're going to do the last 2 questions, and then homework 24 is due, and then you'll have the rest of the class period to work on your study guide.